Our speaker is AI engineer at Q42. He's mainly focusing on making AI more reliable and reducing hallucination in real deployments. Today, he will share practical techniques to control LLM hallucination using variables, query enrichment, and knowledge distillation. Please join me in welcoming Saif Bagmaru. And okay, sorry.
Just before starting the session, may I know how many of you guys know about LLM hallucination? Yes. Yeah, so my session is majorly based on controlling language model hallucinations, the problem that we face related to hallucinations on production level. The title of my session is Taming LLM Hallucination, like from parsing chaos to knowledge distillation. Let me talk about today's agenda. So, basically, we will be exploring the term hallucinations, why language model fails on production because of hallucination problems. Apart from that, we will be discussing what exactly is a knowledge distillation techniques and how exactly this knowledge distillation helps us in uh, reducing language model hallucinations at production level or at level where document ingestion is important, document context is important. So where exact what the let me first explain the term hallucination. Hallucination is basically LLM making up facts even though we feed them the documents or context. So I'm sure you guys must have heard about RAGs, retrieval augmented generation, right? So what we do is we basically feed chunks to LLM. Whatever, if I feed a document, it basically gets converted into chunks, let's say 5 or 6 chunks. And then when I ask question about it, the RAG pipeline basically gives me the similar chunks. Let's say if I ask something about who was Harry Potter, when I feed the book Harry Potter to it, it will basically pick out 5 or 6 chunks and then it will give me information about it. But what happens is you basically there are certain information which LLM fails to digest or incorporate in context window. Basically, there are various reasons such as LLM might not get the right chunk to answer that question, or the question is in such a way that the information that we retrieve from RAG pipeline or the chunks that we retrieve from the RAG pipeline not match with the question or information that we tend to ask. Have you guys ever tried RAG application on any platform or using local models? So what happens is LLM basically the first problem is LLMs hallucinate because they don't get the right information. And sometimes what happens is when I provide the information, there are huge amount of chunks. Maybe if I feed a document, there are like thousands of chunks, and out of those 1,000 chunks, we use 4 or 5 because we probably don't want to overload the context window of a language model, right? The next thing is whatever the traditional RAGs that we use, they all fail if the document structure is complex. For example, if I feed a tabular data or a Excel file, I can't create proper chunks with it, right? So if I feed a Excel table that consists of millions of rows, right? And if I ask a question, can you summarize the entire document, or can you give me top 5 cities where pollution is maybe below that AQI? The main thing that RAG does is it's basically puts in your question and whatever matches with your question, like keywords or whatever, it plugs out that chunks and then gives you answer. But my question is something different that requires critical thinking or maybe using tools. Like in database, if I say the same thing, we convert it into a query, right? My natural language gets converted into a SQL query and I get the right information. So there's nothing like hallucination in traditional database kind of systems, but it exists in vector databases. The problem is the chunking, like how exactly we chunk our documents and store it in vector database. For example, the traditional RAG system, what it does is it takes your document, it breaks down it into n number of chunks. Let's say if I have a book of 5 pages, it will create a chunk of each page, right? So that will be like 5 total chunks, and those 5 chunks get stored in vector database. And every time if I do a query, me I'll pick only 2 chunks. So sometimes the information which is present on third page or fourth page, which might be important, gets missed out, right? Also, this chunking process, the chunks that we give to language model, it basically happens at inference time. Like when I ask a question to language model, the chunks get feed into a prompt, the prompt that we basically designed to answer questions. And at that time, the model decides like how exactly I have to answer question. Now, when we chunk a document, what we do is we randomly provide chunks to it. Maybe this is the third page, this is the first page, and this was the user's question. So you have to give answer to the user. So the cognitive load that LLM does before giving the answer basically gets increases. Like it tries to solve the puzzle before giving the answer. Like, okay, this is the chunk from third document, and this is the chunk from first document, and this is something that user is asking. So how do I put it? So it thinks, and then sometimes what happens is you might have also experienced this on ChatGPT. If you ask a complex question, it basically takes a little time, right? 2, 3, 5 seconds. That's basically what cognitive load is. And if you ask a simple question like what is 2 plus 2, or a very basic question, it basically gives you an answer in like 2 or 3 seconds, right? So how do we tackle it? So we have a smarter approach. So what you do is before ingesting all those documents, you process those documents before querying. Process in the sense you create a knowledge pyramid out of it. So we will be getting to know about it in next slides. The second thing is extract and organize knowledge in layers. So basically, when you create a knowledge pyramid of your data, you store it in layers. The third is think understanding first and answering later. Now you have a structured data. Like I'll be providing you a structured data. This is a chunk from this document, this document. This was the user's question, and this is basically what you have to answer it. So there's not much thinking. You just look at the data and just give the answer. Like what we usually do is, I still remember before an engineering exam, we don't look at the entire book, right? We basically plugs out a few notes, and then we usually look what were the questions that were asked in the previous year, or maybe we pick out some important questions, and then we prepare according to it, because we don't have that amount of time to look at the entire book and then prepare. So we tend to prepare a smart way to study for exams, right? This is exactly like this, but we are taking few approaches. So what we are doing is before constructing a knowledge pyramid, we basically construct it into certain layers. So these are 5 core layers before building a knowledge pyramid out of a document. So we have a recollection. It's like, let me explain it in easier terms. So, for example, if I have like 10 books, and if I have to prepare from those 10 books, let's say I have an exam or a viva upcoming, but I don't have much time. So, what I'll do is I'll think smartly. So, I'll put out those 10 books, and what I'll do is I'll go through it and I'll only sort out the important topics. What are the important topics out of those books? And whatever the important topics I see, I'll pluck it out and I'll create a notes out of it. After creating the notes, what I'll do is, okay, I have different topics, different books. I'll create few folders. So let's say I have a computer science exam. So I'll put all the computer science related stuff into computer science wala folder, and then database wale files in database folders, and so on. Now I have a structured knowledge base in front of me. I have folders, I have everything in front of me. So if I want to prepare, I don't have to go through the books, this book, this book. I just have folder. So I have to prepare for computer science exam. I'll just plug out the computer science wala folder, and I'll go through it and I'll prepare it according. So this is the easiest way how you prepare. So recollection is basically you are seeing your entire documents in front of you, folders. Okay, I know this folder contains this information. Abstracts are like when you create a node out of a certain topic or maybe out of a syllabus, what you will do is you tend to compact it, right? Maybe let's say 2 pages into a sentence or two. So I don't have to go through each detail. I'll know, yeah, this is the summary of it. So this is what abstracts are. So concepts are basically individual facts in simple sentences. So for example, if I read a sentence, so this is the company that put its IPO live in 2022 and they gained this much of revenue and all. I can put it in one word, right? Let's say company X had IPO in 2023 and it generated a revenue of 200%. That's it. So this is what the concepts are. And then insights are basically individual facts in simple sentences. For example, if I'm reading something, reading an article or whatever it is, I tend to create facts out of it. Like, okay, so Apple produced 2 million iPhones back in 2024. So these are simple facts that are important. So you pluck out those facts, and that is what insights are basically. Chunks are something your original raw content from the document. Like when I create chunks, these are the chunks that are present in my database. So these are the 5 layers. That's how we create a knowledge pyramid. I think you will get an like visualization how it basically looks like. So on top of it, you have recollection, then abstracts, then concepts, then insights. So on top of it, I'm looking at my entire document or entire knowledge base. So if user asks a certain question, then I know where exactly that certain concept relies in. For example, if I ask you a simple question, I have 10 folders in front of me and I have to prepare for computer science exam. Uh, what what would I do? I'll basically put out that folder, right? So this is what recollection does. It takes your query and it knows where exactly that certain topic is present, and then it goes into abstract wala layer, concept wala layer, insight wala layer. Since it have a small detailed knowledge about it, so you pick out the information from all of those layers and then create a structured prompt and then you feed that prompt to LLM. So now I don't have chunks from vector database, but I have a very structured information in front of me which I can give to LLM. In that way, we can reduce hallucinations up to 70%. To be honest, I tried it on 20 or 30 complex documents, and I did the same with RAG. And the quality of answers that I found on knowledge distillation technique is quite well. It was able to summarize me the core concept that traditional RAG was missing. Like if I asked a detailed question regarding a research paper or maybe something related to tabular data, it was giving me perfect answer where the traditional RAG was failing. So basically, just to summarize it up, insights are basically your simple facts that are extracted from the documents. Concept are something that you group related insights together, like you put all the papers, whatever the notes you have into a certain folder. Then abstract are basically ultra dense summaries of that entire document. So I have a computer science wala document. I'll put a note on my folder key. This is a computer science wala folder. So this is what abstract is. You identify the folder based on the sticker or name, whatever you put on it. And then recollections. Recollection is basically you are looking at your entire documents, entire folders, and then identifying which one to pick to get the answer. Now, what is the secret sauce behind this technique? You pre-process the click clarity. So instead of seeing messy chunks from vector database, you are now seeing an organized data, right? You are exactly getting what you were supposed to get. The second thing is context is preserved, like important details which we used to miss in traditional rack systems is not happening here. You get the exact context that you were looking for. And the third is, as I speak about, the reduced cognitive load. So LLM just focus on answering the question rather than understanding ki, yeah, this is the chunk that I took from this document and this was the user's question. You basically look at the data and you have to answer it. There is no cognitive load on the language model. Now the key takeaways from the session is process early, not late. So whatever the hard work that you are doing, do it at the ingestion pipeline. So the knowledge base creation wala stuff that I have shown to you, that knowledge base is getting created by pure ML algorithms. No LLM is involved in here. So there is this one thing which is called as contextual chunking. So what you do is you basically whatever the chunks that you have, you give it to LLM, then tell the LLM to summarize these chunks before storing in vector database. So whatever the data that you retrieve, LLM will know, yeah, this is the compressed chunk, or this is the chunks that LLM has given to you, and these are better. But that if the that same thing, uh, if the number of documents are too large, then you can't create semantic chunks out of it, right? There might be millions of chunks that will increase the token cost, of course. So yeah, that is processorily not laid, do the hard work at ingestion layer. The second thing is structure matters. Organize before you ask. So whatever the data that we are feeding to LLM, you have to structureize it before giving it to LLM. Like if I am feeding it a fact, concept, or any information, I should be able to give it in a structured format, not like a missing chunk or maybe something messy or incomplete. This is the entire information related to user's question. You just look at it and just give the answer. Now the third is layer work. So you have different layers, right? Abstract, recollection. So for each and every question, the data might lie in each of the five layers. Like if I'm asking a simple fact, that might lie in abstraction wala layer. And if I'm just asking for a summary of entire document, then the answer to that question lies in abstraction wala layer. So this is how layer works. So if you are building a production grade type of system, so you have to if you want to build it for production, then probably you have to use agents, since there are large amount of documents, so you don't have to go through each layer to answer the question, right? So layer work is something that you can do to get even better answers. The fourth thing is trust but validate. So whatever the answer I'm getting, I still can't rely completely on language models to give me the right answers, right? So I always have to validate answers, like from where it is fetching the answers and everything. Okay, so this was my session. Apart from this, what I'll do is I've created a POC to demonstrate how knowledge distillation works. So I give you the demo of it as well. So this is the interface of knowledge distillation system. This is how a rack system basically looks like, right? So you have an upload button where you upload your files, that is basically PPTs, PDF, etc. So I'll go ahead and I'll browse the files. One of the file that I'm going to upload is related to adaptive rack, the session which Pratik gave. The second is my resume, and third is document related to loan policies at QAD42. I'll go ahead and I'll put these documents and upload these files. These files are uploaded. Now comes the ingestion layer wala process where you perform ingestion pipeline. So I have a few options here. OCR, basically OCR is something, if you have images in your documents, you can't feed those images, right, to LLM directly. Even if I have to store it in vector database, I can't store images with the embeddings. So what I'll do is I'll feed those images to LLM and tell the LLM to summarize what those images are. Maybe if there is an image of cat playing with a ball, then we can write a text, and this is an image placeholder where cat is playing with the ball, right? So this is what OCR is. And now we have chunk size. Chunk size is basically the size of chunk. A chunk is basically a collection of words. So that would be 800 words in per chunk. That's how you also measure how many tokens that you want LLM to feed. There's a limitation, like in GPT you have a context window of 16,000. For Pro you have 48,000 or 64,000, like that. And now quality threshold. Quality threshold is basically, so in vector database we don't have SQL query type of thing. you basically takes a sentence, you convert it into a query embedding, and then you retrieve the answers. So quality threshold is basically you're telling ki, how strict it should be. Like if I ask a certain question, then what if I reduce it to 0.3 or 0.2, it will be very strict. So it's like you're basically retrieving the exact keywords that I am putting in. And if you increase it, then it's like yeah, you can explore few more words apart from it. So it's the threshold that defines it. So I'll go ahead and I'll process these three documents. So whatever is happening right now is basically the machine learning stuff on the back end. It has been processed. I'll go. Now you can see I have uploaded three documents, right? One was loan policy, the second was my resume, and the third was adaptive RAG. If I click one of it, I can see the number of chunks that has been created, how many pages were there, and how many concepts got created. You can see everything that the ML model has created. Like these are the document section, basically headings and other stuff. Then key concepts. Concepts is basically your simple summarized facts. Then insights. Insights are basically smaller facts that you derive from the documents. Everything you can see here. So before chatting with LLM, you can verify the data that you are getting is correct. The model have put everything in the right place, right? Concepts, the number of chunks, the number of sections it has created. The third thing is chat. So in order to demonstrate this, we have three models: Claude, Sonnet, Haiku, and Mistral. And we have a search depth, which is light, medium, and deep. Then thinking mode, and I have a filter which is a document filter basically. So if I want the LLM to give me answer from a specific documents only, then I can go ahead and check it. So search depth is basically how far you want to search from your documents. Like if I provide light wala depth, so it will just answer from few layers that are on the top, right? Maybe abstractions. So if you are about to question very simple things like summarization wala thing, or maybe something like, can you tell me about this subject, can you give me a brief summary, what is this subject about, these kinds of thing, you can use search depth like light. So it will give you faster answers. But if you want to go deep, like I want to learn about this specific topic, then you can go on medium and deep based on your questions or what you are going to ask about. What I'll do is I'll go ahead and I'll remove one filter. Now one more thing is, if you want even better answers, for example, if I want to ask specific something specific to the documents that I have uploaded, and I know whatever I'm going to ask about lies in this document, so I don't have to add these two documents, right? So I'll go ahead and I'll ask a question. What is adaptive RAG? You may see a little delay here. The delay is because before fetching the information from the database that we have, we perform layer abstractions, right? We fetch the answer from specific layers and then feed that information to LLM. So you may see a little delay, but if you have a laptop with high-end GPUs, you may get response even faster. So now, based on my question, it has given me the answer. Adaptive RAG is an intelligent document answering system that learns from the user feedback, continuously improves. Now, the next thing is debugging. Debugging is something that we do on our production application, right? We do debugging because we want to see everything is working fine as we have designed. But in these kind of system, we don't have that debugging kind of thing. So we have something called as citations. Citations are basically where your LLM takes the context from. So based on the answer that it has provided, on front end you can see those small pointers P1, P2, P3, right? So if I click on that, I can see the source from which it has taken the context from. So whatever the question, my question was, so my question was related to what is adaptive RAG, right? So it has taken the context from page number 1 from the adaptive RAG documents, and this was the chunk that it took the information from. Now you can see, so on the dashboard itself, I can verify whatever whatever the answers it is giving to me, is it from the document or is it making it up? So that's how you actually recognize if LLM is hallucinating or not. You can just, you can simply read the document and then verify the answer from LLM, and you can just check if the answer is correct or not. The similar thing is, since I have only selected one document, and if I ask, the expected answer should be no, I don't have any context about Saif, right? Since I haven't given it my CV, it is saying that the context that I am getting is related to adaptive RAG. So if I go ahead and select my resume and then I ask the same question, it gave me the answer, right? So we have these filters. So why these filter matters is irrelevant chunks that you are feeding to LLM based on these filters, right? These filters are like, so these are the documents specifically where I want my answer from. So if you want to be more precise towards it, you can use these filters. And yeah, this was my session all about.